Faisal, I'll start this question. Draw the shear and moment diagram of this beam. Look at this beam. Had this distributed force, 400 pound per feet, point A, and then 4 feet for this distribution. Look at this distribution. It's normal distribution. And then 2 feet to point B. Look at this. This beam there's a joint here at point B. And then point C, there is a moment 900 pound per feet. Okay, how could you draw the shear moment diagram for this beam? So let's do it like this. We put the question like that, 400 feet, and then we should try to find out the reactions. So we have this one should be done into two reactions, one AX, one AY, and one moment, because this type, it's not a pin, it's not a ruler. This type of reaction is one AY, one AX, and one moment at A. So look at that. It's connected to the wall, so it's not a pin. So this will have one reaction at the X, one reaction at the Y, and one moment. Okay, so you change A to this. AY, AX, and moment at A. You should choose any directions. So if you just make it AY to the top, if you make it AX to this side, to the negative, if you make moment A like this, and if it's negative, it's going to be the opposite. Okay? So let's see the distribution. The distribution, according to what's given, it's 400 pound per feet. And remember, 400 pound per feet, and the whole thing is 4 feet. So 400 pound per feet times 4, which is 1,200. So 400 times 4. So this is going to be in the middle. Look at that. It's 4 feet. So in the middle of the 4 feet, you will have, because this is a rectangular, 4 feet. In the middle of this, 2 feet to the right, 2 feet to the right, 2 feet to the right, and 2 feet to the left, and 400 times 4. Okay? So this is the equivalent force for this distributed force. 400 times 4. So we cancel this and we put only one force, and this represents this rectangular distributed force. Now, we should take this beam off, because remember that there was a pin here. There was something that connect this to this. So we take it off, so you could see that this point B, there should have BX and BY, and of course if you assume it's compression, the other one gonna be compression, because this is the other side. This is BC, look at this, BX, BX, BY, and since you assume this is compression, and since you did this BY like this is gonna be the opposite. Okay? Because you could assume here BX, and this is going to be the opposite of BX, and BY, and this is going to be the opposite of BY. And the other one is you should see that there is a force, either you call it CY or you call it NC, that's up to you. So this is the force here, because this is, you can see, this is the ruler. So you should have only one force in the Y. You could call it CY or you could call it NC, it's up to you. And now, so since we dejointed the beam because of the pin, we take the first side, the easy one here. The first way is step number 1. You should take moment at point B. Moment at point B, it will cancel BX and BY. Okay? Now you could find NC. Or you could call this one CY. It's up to you. It's in the Y-axis. Let's call it NC. So once you take moment at point B, look at this. NC will put it that way. It will put it what? In the plus. So NC times the perpendicular distance, 3 feet. So NC times 3 feet. And then you have this one, it's going what? It's going clockwise, so it's negative. Clockwise moment is negative, so it's minus 900 equal to 0. At moment at point B, there is nothing else, only this force times the distance and the moment. So when you resolve this equation, you will get NC is equal to 300 pounds, which means that this reaction we found C at the Y direction, we find it, or NC is equal to 300 pounds. Now, you could take moment at C and cancel NC and find, now remember Bx will be 0 because Bx is in the same direction of point C. So summation of moment at C, it will be By, and this one, gonna take it like this, counterclockwise, By times 3, By times 3. And of course, summation moment at C, you should take the moment around it as to include it. So this is gonna be what? This moment gonna be also negative. So minus 900 equal to 0. Now By is equal to 300 pounds. Let's do after this, what's other thing? Summation of forces at the X. So you can see that there's nothing in the X, there's only one X, Bx. Bx is equal to 0. Now, since we take this joint and we find everything, the whole thing here is to find NC. Now let's take this joint, the other side of the membrane, or the beam. Okay, so we take this side. Now let's take moment. The best is to take moment at B. At A here. No, B you don't have to, because we have Bx and we have By from the other side. We have these. So these are known and this is known. So take moment at point A to find the moment A. Summation of moment at point A equal to 0. Now this is going where? Counterclockwise. So it's a plus. And this is, if moment at point A, this is gonna push it like that, negative. So minus 400 times 4 times the distance between here and point A, 2. So minus 400 times 4 times 2. Okay, what other force? Remember, Px will make it 0 because it's in the same line of action. So this one gonna make it what? This moment at A, this gonna push it that way. That's a plus. Remember, 2, 2, 2, 6 plus By times 6. And now, remember By, we found it here, By we found it here, 300 pounds. So By 300 times 6, and then the minus 400 times 4 times 2, you could find the moment at A. Moment at A is 1,400 pound feet, remember? So this is plus, so pound feet, this is the directions. Now summation of forces at the Y equal to 0. Since we found summation of moment, now we find the moment. Now we know By, we know this, we could find summation of forces at the Y and we could find Ay. So summation of forces of Y equal to 0, Ay going plus, this is going negative, and this is going plus By. And remember By, we found it before, 300 pound. So Ay is equal to 1300 pound. So Ay is 300 pounds. Now, summation force at the X, remember here there is Px. Px was 0 before. So there is nothing else in the x-axis except Ax. So Bx is 0, Ax should be 0. So Ax is equal to 0. So now we find the reaction. Now we go and find everything else. Let's find the shear moment diagram. Remember, the shear, we look only in the forces in the y-axis. The forces in the y-axis. So Ay was different. What was the Ay here? Ay is 1300 pounds. And what was, let's say Cy or NC? Cy, it was Cy or NC 300 pounds. So 1300 and 300. Let's look at it like this. Part of the shear moment diagram, I would like to tell you this now. If the top loading is straight line, the shear gonna be linear, and the moment gonna be non-linear like this. This is the first. You should put this in your notes so you know it. This is the loading, this is the shear, and this is the moment. What will happen if the loading is like this, linear? Then the shear will be non-linear, and the moment will be also non-linear. So everything depends on this. If this was normal distribution like this, the shear would be linear. If the shear was linear, the moment will be non-linear. If the loading was linear like that, not normal, so the shear would be non-linear and the moment will be non-linear. Now, let's look at this. Let's look at this. Now, remember, this is the actual beam. And remember, this is normal. So what's going to be the shear? The shear is going to be linear. Since this is normal, the shear is going to be linear. Just memorize this and just put it in your note, in your sheet. So let's do the shear. Now, do you remember what was the shear force? What's AY? 1,300. So we do this. We do a line like this. Okay, and we go. We call it shear V in pound, and we call this X feet. So we go 1,300 since the AY is 1,300, and we stop at this point 1,300. And remember, since this is normal, so it has to be linear. Now, what is the last value? So this is the continuation. We have to go all the way until this point. Okay, so it's 1,300. How could you determine this? Remember, this is 400 times 4. That's what? 400 times 4. 4 times 4 of 16. So 1,600. And 1,600 down. This is 1,300 positive minus 1,600. It will be minus 300. So gonna go from 1,300 to minus 300. Remember, at the end, minus 300. Okay, so this is what I did. So, okay, so we stop at this point. Now we need this point when there is a zero shear. Okay, the way we do this, how could you find this 3.25? Is to find the big triangle. What's the big triangle? It's 1,300 plus 300. Okay, so we do it like this. The big triangle, 1,300 plus the 300, that's 1,600. So we do 1,600. And what is, for the big triangle, what is the whole distance here? It's 4 feet. So we do it like this, 1,600 over 4. Now, what is this small triangle? 1,300 over x. So we need to find this now, it's 3.1. We need to find this x. So 1,300 over small x. Now we can find x right now by solving this. This is 4. We can find x is equal to 3.25. So this location, which is 0, is from here 3.25. So you could find the 3.25 from here. And since it's 4 feet, 4 minus 3.25 will give you 0.75. We need these distances because now we're going to find the area under the curve. So now it is minus 300 here. So let's go at this. Here there's no loading whatsoever. So it's going to be straight. If there's no loading, which means that it will continue straight, normal, there is no problem until it reaches here. But remember here there is a reaction up. Remember the point C. Let's go at point C. Normal C, 300 pounds. So it's gonna go up 300 pounds. So if this is minus 300, you're gonna go all the way straight, and then here you're gonna go up 300. So minus 300 plus 300 gonna go to 0. So this is the shear diagram for this beam. Now let's find the moment. The moment is, first of all, you have to find the area under this triangle. Remember, it's 1,300 here, 3.25 here. So it's 1/2 1,300 times 3.25. So 1/2 3.25 times 1,300, that is 2,112.5. Okay? So, and remember, here there was a moment originally, moment at A. Let's go, what is the moment at A that was given here? Aha, look at this. That's 1,400 pound per feet. So you have to start with a moment here. And this is going what? This reaction like that, it is negative. I know it's counterclockwise, but here you should make it negative. So a moment 1400, we got it from here. Okay. So minus 1400, and since the area under this curve, so we start from a 0, from 1400, and since this is linear, this is gonna be a curve. This is not linear, this is a curve, like a concave down. So minus 1400, remember the area under this curve, because at this point where the shear is 0, you will have a maximum moment. Okay? And this is the maximum that you're gonna have throughout the whole beam. When shear is 0. Shear is 0, maximum moment. So, minus 1400 plus the area under this curve to find the moment at this point. The area under this curve, we found it, 112.5. So, minus 1400 plus 2112.5, remember, it equals 712.5. This is the moment at this point. So you go concave down, that's not linear, that's concave down, 712.5. Now, what is the moment at this point? Moment at this point, you should find the area under this curve. So 1/2 0.75 times minus 300. 1/2 0.75 times minus 300, this is minus 112.5. And what was the thing before? 712.5 minus 112.5, you will get, look at this, 600. So it's still concave down, 600. Now we came to this. Remember here, look at this. This is normal. Normal shear, you will have down what? Linear. So 600, and it is all the same. So minus 300 times what? 2 and 3, 5. So minus 300 times 5, minus 1,500. Minus 1,500, and you have here what? 600. So 600 minus 1,500, you will go down to minus 900. So minus 900 here, and remember that there is a moment here, and this one is going in the negative. You make it plus, opposite. So it is minus 900, and you go up to 0, because minus 900 plus 900, you go to 0. So this is the moment. And of course, at this point, the moment is 0. Why? Because it's a straight line. You have to intersect this line, because you're going from plus to a negative. And this moment is 0. Where? When there was this joint. Remember this joint that it was at point B, and when we cut the beam into two, one right and one left. So this has to go to 0. You could recheck it, but you don't have to, since just put that 0 at this point. Okay? So this is example 780, first one.